Hello guys, welcome back to my channel Memo African Motives. Still working on engineering science and 3, so we shall have actually a continuation. Still we are still focusing on question papers, guys, so that we see how they ask these questions and we prepare ourselves actually for the exams which are ahead of time. So if you're new, guys, you can consider subscribing so that you become part of the family Memo African Motives, as we shall be working on question papers and revisions as we prepare ourselves for the exams which are ahead. So in this platform we have a question on moments that you're going to focus on. So the first question is to state 2 conditions for a beam to be in equilibrium. Okay, so these conditions, we talked about them previously, if you still remember, guys. So the conditions for a beam to be in equilibrium, these are the 2 conditions that we can have. Sum of upward forces is equal to the sum of downward forces from the Newton's from the third law then of Newton's laws. Upward forces, the sum that is for upward is equal to the downward. So you can use also this one for moments. You can actually calculate this. Anti-clockwise moments equal to clockwise moments. Okay, then the second one, the algebraic sum of moments about a turning point is equal to 0. So you can actually take this as a consideration for a beam to be in equilibrium. So that's what we have there, guys. Okay, so let's see what we have on question 2.2, where we are given Fig 1 shows a light horizontal beam ABCD of uniform cross-section loaded as shown. The magnitude of support A is 32,22 kilonewtons. So we are given the magnitude of A there, which is actually 32,22. So this is something like, hey guys, I don't know where I'm obtaining this, but this is 32,22 kilonewton there. Okay, I don't know where I'm having this, but that's what we are having there. So that's your A there. And calculate the magnitude of support D by using Newton's third law. So which third law? I think I talked about this previous law. Guys, not to mistakenly do this question, just redraw. It doesn't take you much time to do this actually next time, so that you know what you are working with. You don't do any mistake there if you have got a diagram that is in a simplified manner. Okay, so this one, I've got a support. So the major part here is the distributed, but everything is fine. The support here at AE as it is 1 meter and so forth. So the support as it is here, this is our A, which is 32,222 kilonewtons, like that. And we've got 1 meter. Then there is a force there of 10 kilonewtons if we cross check there. So you've got 1 meter there. All right, then let's focus about this distributed load here between B and C. So from A to C, we've got 7 meters. So it's 7 minus 1, which is 6. So you'll be left with 6 meters in between. You'll be left with 6 meters because it's supposed to be 7. So this one is 6, but from here to here is 7. Then this distributed, we are now going to write it as a concentrated like this. But now it's going to divide this distance into 2 equal parts, remember. So you're going to divide 6 divided by 2, which is 3. So this one is going to be 3 meters and this one is going to be 3 meters. But here we shall have a single force now, which you're going to multiply this 5 kilonewton per meter by the number of meters which is in between. From this point to this point is 6. So 6 times 5, that's 30 there. So you've got 30 kilonewtons like that. All right, then we are done. We end with this force at 30 there. We're going to have another force again at 30. So take note, guys, here we are distributed here, so don't forget that. All right, then we are now at C here, so just represent our C. This will be, then what else do we have? Then a distance of X here to D. So there's a distance in between and we have got D. This is X. All right, so a simplified diagram. Now we can calculate the magnitude of D by using Newton's third law. Okay, so which one is the Newton's third law? This is the one that I was talking about, guys, about the sum of upward forces being equal to the sum of what? The sum of the downward forces. So you can actually use this being equal to the sum of the downward forces. All right. So the upward forces, these are the supports. We are referring to the supports here. Okay. Then these are the point loads. You are referring to point loads there. Okay. The ones which are pointing downward. So of the support, we are given one of the support, which is this one, and we need the unknown, which is D. So we're going to take this A plus D. These are the ones which are going upwards. That's your upward, this one. And these ones going downward, that's your downward forces. Okay, so you're going to take this and add it to D together. So 32,222 is plus D is equivalent to those ones which are going downwards. Which one? This 10. The distributed now, it's now a concentrated with 30 there. So you're going to take 30, and this one is 30. So you're going to add these ones which are going downwards. So that's 10 plus 30 plus another 30 there. All right. So you're going to combine this. If you add this, you're going to obtain 70 there. Okay, then transpose this to this side. It's going to be minus. So it's minus 32,222. So if you subtract, guys, you're going to have the magnitude of the support D as 37,778 kilonewtons, because the other forces were in kilonewtons. So that's our D, guys, which is 37,778. All right, so we now have our D here. Let's see what we are going to have. So that's our first question. And the second question, which is a continuation, is 2.22, which is calculate the distance x by taking moments about support D. Take note, we are given where to take our moments about support D. All right, so this is what we are going to have, guys, about support D. This is our D here. All right, so this is 2.222. So taking moments about D. All right, so we are going to take moments, taking moments about D. All right, we are going to take moments about D. So what are we going to have here, guys? Let's see. According to this D, this is what we have, guys. I'm gonna put this as our D here. So I want us to cross-check. Remember, we always need this movement, the clockwise movement, the clockwise movement like this. This is how the clock moves. Okay, so this is our clockwise, and the anti-clockwise, which moves this direction now. So this is anti-clockwise. All right, so according to this here, D, this support A is moving this way to D, which is clockwise, as you can see, this way, this way, this way, and this way is clockwise. Okay, what about these ones? These ones, they are moving this way, which is anti-clockwise. So it means we shall use the moments here, the sum of moments of clockwise to the anti-clockwise. So sum of moments in clockwise should be equal to the sum of moments in the anti-clockwise, that is anti-clockwise moments. So for clockwise, we have got this, but we have got a distance back to D here. So I want us to see, guys, because this from C to D there is X here. From C to D there is X. Okay, so let us take this, guys, from this point A to C. Remember, we've got a distance of 7 because this was 1 plus 6, which is 7. Everything together here combined together is 7. In between here, because we've got 6 plus 1. 6 is from this point up to this point, but everything from A to C is 7. So which means the distance from A to D, this is going to be 7 from A to C plus X, because there's another. Let's say, just like what we did here, we said 1 plus 6 to obtain 7, but this one it's X, so it's going to be 7 plus X. And you can't simplify 7 plus X, so you have to write as it is, okay? So this is going to be moment force times distance. So the force is 32,222 from what? From A here back to D. So this is the force times the distance. So the distance we said is 7 plus X. So it's times 7 plus X. Okay, so like we saw that in the clockwise, those which are moving in clockwise, we only have this one only. So we are done for the clockwise. Let's move on to the anti-clockwise, which is these ones, 10 back to D. So we now have the anti-clockwise now. So 10, we have got 6 here. From B to C is 6 plus X, because we need 10 back to D. So it's this 6 here plus X, take note. So it's 6 plus X. So it's force times distance, which is a force of 10 times the distance, which is 6 plus X. All right, we move on to this force of 30, but there's a distance of 3 plus X. So it's 30, and there's a distance of 3 here, and there's this X. So it's 30 times 3 plus X. We move on to another one. We've got this one, 30 here, and there's a distance of X. This one is direct, there's just X here, so it's 30 versus X. So that's 30 times X. So we are done, guys. We have taken everything. So we need now to combine everything, guys, and see what you're going to do. Okay, so here you have to expand the brackets. 32,22 times 7, you're going to obtain 225. That's 225,554 plus 32, times X is going to remain as it is, which is 32,222X. All right, which is equal to 10 times 6, which is 60, plus 10 times X, that's 10X. All right, plus we move on, 30 and 3 is going to give you 19, plus 30 and X, which is going to give you 30X. Okay, and this one you just multiply 30 and X, which is 30X. So there's nothing there, guys. Remember from your mathematics, that's how you simplify this. Okay, then you just need to collect like terms. So let's just leave this for the meantime. Let's just leave this for the meantime. Plus here 32,222X, which is equal, so I'm just going to combine the numbers. That's 60 plus 90. These are the only numbers that I have. I'm going to obtain 50 there, 150. Okay, then we've got 10X, 30X, and 30X. So you add 10 plus 30 plus 30, which is going to give you 70X, because we've got X there. All right, now we can transpose, collect like terms. So I'm going to, because this one is the smaller and this one is a bigger one, so I'm going to transpose this to this side. So it's going to be 70 minus this one, which is going to give me 37,778X. So take note, guys, I transposed this to the right hand side, is going to be a minus. Okay, I transpose this 150 to this side, is going to be also a minus because it was a positive. So it's now 225, whatever that we have, minus 150 there, which is going to give us 75,554. This is what you're going to obtain. So to find X, definitely I have to divide by 37, whatever that I have here, 37,778. This is gonna cancel here. So therefore our X is going to be something like 1,999, another 947, guys. If you see, if we round off to 3 decimals, this is going to give us 10, 10, 10, up to changing to 2. So it's going to change to 2. So our X, therefore our X is going to be 2 meters. So as you can see, guys, the last part was just a matter of solving normal equations from your mathematical skills there. I think, guys, we are used to solving these equations. It's something that you are used to, so you can actually try and see what was actually happening there. Okay, anyways, that was it. Then the other question was to draw a fully labeled shear force diagram using a suitable scale. Show all the main values on the diagram. Okay, I think I talked about an easier way in our other classes where we had shear force diagrams that okay, let's just put this into a diagram. It's good to explain whilst we have a diagram here. Let's explain with a diagram like this. All right, so remember what I told you guys, that from a shear force diagram, everything is going to start at 0. So this one, our force is in kilonewton, so this one is going to be 0 kilonewton at this point. Okay, then what is going to happen? We started at 0. Okay, so I'm going to start here. So this is what we started at 0 there. All right, then what happened? Let's go to the diagram. Let's get back to our diagram here. The first thing, there is at the end, there is a support, and we know that a support you add because it's going upwards. So there's a support of 32,22. So this is what you're going to add, the support here of 32, so it's going to be 0 plus 32,222, which is just going to remain like that because like there's nothing, you haven't changed anything here. So which means it shall move upwards up to 32,22. So you just go upwards, guys. I hope it's gonna be clear. Just go upwards. Let's say this is our 32,22. Let's say this is our point, 32,222 kilonewton. Let's say this is where we are now. All right, then what happened? There is a distance between, before this 10, there's a distance of 1 meter there. So every distance I told you is represented with a horizontal line. So sorry for that, guys. So you're going to represent with a horizontal line like this. So something, we are now at that point. Then what happened? There's a point load, and the point load is always a negative because it's pointing downwards. So it's going to subtract. So you're going to subtract 10 because it's going downwards, direct 10. So where are we subtracting 10? We are going to subtract 10 from where we are now at 32, which is here at 32,22. So this is not for you to mistake, and this is what you just do, minus 10 like this. So you are going to obtain 22,222 like this kilonewton. So you are now at 22,22. So this one is going to drop. 22, is still above, so just drop maybe to this point. It's still above. So this is 22,222 kilonewtons like that. All right, then there is a distributed load here between. So take note, a distributed always supposed to be like this, okay, a diagonal like that. But this diagonal, we are going to subtract 30 to meet the point. So we're going to subtract 30 because it's facing downwards also. So from this value we subtract 30, which means from this value where we are now at 22,222, you just subtract 30. So from your calculator you are going to obtain negative 7,778 when you subtract that. So you are now at negative 7, which is a negative, so it's in this region because this is positive region, and here you are at 0. So which means once you cross this line, you are now in the negative region. So it can be something like this, in the negative region. Okay, so let's say this is our point here, which is minus 7,778. So this is minus 7,778 kilonewton at this point. Okay, so that's how you represent a distributed load there. Then what happened after the distributed load? I want you to see what happened. This is after the distributed load. There's a point load direct after. There's no distance in between, it is just direct after. and this a point load is going downwards, which means it's a negative. So we are going to subtract again another 30, this one. All right, so from this value you subtract 30. Okay, so from this value as it is, you subtract 30. From your calculator, you subtract 30, you're going to obtain negative 37,778, which is kilonewtons. So this one is going down, since we saw that there is no distance which was in between, so this one is just going to go straight downwards. Straight. There is no distance, so there is no horizontal movement. So this is, let's say, where we are now at minus 37. Yes, this is minus 37,778 kilonewtons, something like that. Okay, then what happened after this? There's a distance in between before the support, so you're going to maintain a certain distance. So there's a distance here, something like this. So we have moved our distance, something like that. Okay, then after this distance, what is going to happen? There's a support which is facing upwards, and anything that faces upwards is a plus. So now at minus 37, where we are at minus 37,778, remember this is where we are now. We are going to add 37,778 of what? Of this support here. This support is 37,778. So if you add this, you are going to obtain 0 kilonewton. All right, and 0 kilonewton is on the horizontal, which means we are going to meet this on the horizontal like this. So it's going to be like this on this point. That's where we have 0 kilonewton. So now it's a closed figure, as we can see. So which means these are in equilibrium. The beam is in equilibrium like that. Okay, so guys, that's how actually they can ask these questions, and how you actually, or what you're supposed to answer. So like I said, this is positive there, so definitely this is a negative. Okay, so that's it guys from Mason African Motives, working on engineering science, past exam papers. In this case, we're working on moments. So till we meet again.